Session 8.1 Compressed Numbers. The imaginary unit I. We're gonna let I equal to square root of -1. When you take square of this equation, you're gonna get I squared equal to -1. Compressed number. If A and B are real numbers, then any number of the form A plus BI is gonna be compressed number. And the A here, we call this as the real part. B, that will be the imaginary part. When you have the compressed number A plus BI equal to C plus DI, if and only if A equal to C and B equal to D. If A equal to 0 but B not equal to 0, then we're gonna say this compressed number is a pure imaginary part. For example, 3i. If A and B are not equal to 0, then the compressed number is a non-real compressed number. A compressed number written in the form A plus BI or A plus IB. This is called the standard form. Compressed number A plus BI for A and B real. So this table, they separate all those numbers. We do have a natural numbers, whole numbers, integer, rational, and irrational. The expression in the square root of a -a. If a greater than 0, then square root of -a equal to I square root of a. You could think about it, square root of -a equal to square root of -1 times square root of a. And then square root of -1, that will be equal to I. Example 1. White has the product of real number and I using the definition of square root of -a. Okay, first one. This guy, that will be I times square root of 16. And square root of 16, which is going to be 4i. Same idea, square root of -1, which is going to be I. And then I times square root of 70. You can't break it down this number. That will be 7 times 2 times 5, right? So this is going to be your final answer. This guy, that will be I square root of 48. 48, we could break it down to 16 times 3. Square root of 16, which is going to be 4, right? So 4i square root of 3. Solve each equation. Take the square root for both sides. Make sure you're going to add plus minus. And this guy, square root of -1, which is going to be the I. Square root of 9, that will be plus minus 3i. So that will be the solution set. Same idea, I'm going to subtract 24 for both sides. Take the square root. And it will become plus minus I square root of 24. And then 24, that means 4 times 6 here. And then square root of 4, that will be plus minus 2i square root of 6. Okay, that will be the solution set. Caution, when working with negative radicals, use the definition square root of -a equal to I square root of a before using any other rules of radicals. For example, in the algebra class, we learned that square root of c times square root of d, that will be equal to square root of c times d. This is valid only when c and d are not both negative. For example, you can't just multiply it. you can't apply this rule when you're working on the negative number, okay? This is not equal to square root of 15. So what we're gonna do, first, we're gonna apply this formula. That will become I square root 3 times I square root of 5. Okay, and then I times I, that's I squared. And then I squared means negative 1. Okay, so highlight this guy. Don't multiply it with the negative number when you have the square root. Okay, example 3. I want you guys try to do it by yourself. Okay, first one, that will become I square root 7 times I square root of 7. And then I square times square root of 7 square, which is gonna be negative 7. B, that will become I square root 6 and I square root of 10. And then this is a positive number, so I could put it in the same radical. So that will become I squared times square root of 60. Simplify it. You should get negative 2 square root of 15. Okay, C, that will be I square root of 20 over I square root of 2. The I, you could cancel out. And then, since this is a positive number, you could put it in the same radical. So that will be square root of 10. Okay, this one, that will be I square root of 48 over square root of 24. And then, under the same radical, 48 divided by 24, which is going to be rad 2. Example 4. Write this form in the standard form, a plus bi. Okay, so let's simplify the square root of negative 128. We're gonna break it down. So we could make it like negative 64 times 2. Okay, because you know what is the square root of negative 64, right? Which is gonna be 8i. We plug it in, and then we could factor out the 8 here, but you know on the denominator we only have a 4 to simplify. So I just factor out the negative 4. So I just factor out the 4 here. And then cancel out. So that would be my final answer. Okay, this is the standard form, a plus bi. Addition and subtraction of compressed number. When I have the compressed number a plus bi and c plus di, I could group it the real part, add it up, and then group it in the imaginary part and then add it up. Do the same thing for the subtraction. Okay, that will be a minus c plus b minus d. Okay, I want you guys try example 5. You could think about just like combining the 9 terms. Okay, so real part will be the 9 terms, imaginary part will be the 9 terms. So when you add it up, you should get 1 plus 2i. B, you should get negative 10 plus 10i. Okay, multiplication of compressed number. When you want to multiply the compressed number, you could use the FOIL method. Just distribute one by one. So A times C, and then A plus DI, and then BI times C, and then BI times DI, and then you simplify it. You don't have to memorize this formula, okay? Let me show you the first example. So use the FOIL method. So 2 times 3, I'm gonna get the 6. And then 2 times 4i here. Okay, and then here, negative 3i times 3. And then negative 3i times 4i. Okay, do your calculation. That will be 6 plus 8i minus 9i minus 12i squared. These two, you could combine the 9 terms, and I squared, which is going to be equal to negative 1. So you should get 18 minus I. Okay, B. You could use the formula A plus B squared. That will be equal to A squared plus 2AB plus B squared. Okay, you should get this. And then I squared, which is going to be negative 1. Plug in negative 1 for the I squared. Final answer, 7 plus 24i. Okay, last one. Remember the formula A plus BI times A minus BI. That will be A squared minus B squared. Okay, which is 25i squared here. And I squared, that will be negative 1. Final answer, 61 here. Straightforward, right? Okay, property of compressed conjugate. For real numbers A and B, we do have the formula A plus BI times A minus BI. That will be equal to A squared plus B squared. Okay, what's the quotient in the standard form A plus BI? Since on the denominator, we only have the imaginary part. So what we're gonna do, we could just multiply by I over I. Okay, we try to get out of the compressed number on the denominator. So we could multiply by I over I here. Distribute the I. And then I squared, you could replace with negative 1. Simplify it. And then I factor out the negative 1 here as well because I tried to simplify with the denominator. So final answer will be 2 minus 3i. Okay, which is going to be the standard form A plus BI. Okay, B. On the denominator, we do have the compressed number A plus BI. So what we're going to do, we're going to multiply the conjugate of the denominator. Okay, remember the conjugate, when you have a 2 minus 3i, the conjugate will be 2 plus 3i. So on the top, you could use the FOIL method, distribute one by one. And then on the bottom, you could apply this formula. Right? A plus BI times A minus BI equal to A squared plus B squared. Okay, that's no more I squared. Simplify it, you're gonna get 13. So we want to write it in the standard form. So that'll be 5 over 13 plus 14 over 13i. Okay, solve a quadratic equation. Solve this equation. This is a ax squared plus bx plus c equal to 0. Right? We try to rewrite this guy. We subtract 6x for both sides. And then we know that this quadratic equation won't be able to factor out with real number. So let's apply quadratic formula. Okay, plug it in, simplify it. Square root of negative 144. So that will be I square root of 144, which is going to be 12i here. And then we're going to factor out the 6. Simplify the 6 and the 18. You're going to get 1 over 3 plus minus 2i over 3. And that will be my solution set. Okay, powers of I. You know I to the first power equal to I. I squared, that's equal to negative 1. If I multiply by I again, you're going to get negative I. Negative I times I, that will be negative I squared, which is going to be positive 1. Okay, you could try to keep multiply by I to see what is going to be the next one. And I want you guys try to simplify each power of I. Okay, I'm gonna teach you guys how to do it. Okay, example 9. Simplify each power of I. When you have the exponent, this is even number. Okay, even number. It can be divided by 2. So what you're gonna do? I'm gonna put I squared 2 times 20, that's equal to 40. Right? And then you know what's I squared, right? I squared equal to negative 1. So negative 1 to the power of 20, that will be positive 1 here. Okay? When you have the even number of the exponents. How about when you have an odd number of exponent? What are you going to do? You're going to take out one of the I. Okay? So this guy become even number again. For the I to the power of 32, you're going to use the same technique just like the part A. And then the I, you just keep it. Okay, 2 times 16, that's equal to 32. I squared again equal to negative 1. Okay, so even number, the negative goes away. So that will be equal to I. Last one, I to the power of negative 3. So this is, so that's a trick for these questions. I could do I negative 3 times 1. Okay, and then remember what is 1 equal to. Go back here. 1 is going to be equal to I to the power of 4, or I to the power of 8. So whatever, when you have the exponent, that can be divided by 4, which is going to be equal to 1 here. Okay? So I'm going to change it to I to the power of 4. And then I could add it up. That's going to be equal to I. If you have the bigger number, for example, you do have a negative 6, you may want to make it like I to the power of 8. Okay? That's it.